Hello everyone, my name is Naveen Terra. I'm the VP of Engineering with Environmental Potentials up here in Salt Lake City, Utah, USA. I've been with this company about 15 years now, helping developing power quality solutions for the worldwide market. I designed highly scalable surge protection devices and low-pass filters for the residential, commercial, and industrial sectors. Today, I would like to take this opportunity to introduce you waveform correction technology that Environmental Potentials has patents on that can offer to the Philippines market, which can protect, prevent, and optimize your electrical distribution system for all the negative anomalies that you get from the poor power quality. All our products are made in USA, and we proudly sell it to the Philippines market. We have an office in Manila, which is in Quezon City. We've been helping Philippines since 2015 across all the small islands that you have, all the way from up north, all the way to the south. Coming to our company history, Environmental Potentials started its R&D in 1999, developing low-pass filters. Our product line primarily focuses on making SPDs, higher order harmonic filters, and other custom filters for the worldwide market. Our filters are installed on your main panel of a distribution system with a warranty of up to 10 years. I joined the team in 2007 and added many more filters to the product list. Environmental Potentials constantly learns and adapts the newest technologies that are available in the market so that we make sure that our R&D is pretty aggressive, the constant improvements to our product line with an extensive expertise in the power quality. Depending on the requirement and the application, we have a wide variety of power quality filters. We are very successful with the automotive, oil and natural gas, manufacturing, healthcare, and universities. We sold more than 150,000 custom filters to the date. All our designs are patented and protected in the US, Canada, China, other major Asian countries. All the EP filter family is designed and manufactured in the United States. As I said in the past, we've been helping the Philippines market since 2015. Okay, now let's start with discussing about the electrical loads that we have in the facility today. Majority of the electrical loads are now modern. They're highly sophisticated loads that you see, which are very fast, efficient, and pretty smart. The new loads rely on highly sensitive electronic components. If you see into the next slide, where I have some examples. In the past, we used to have incandescent bulbs, which are pretty resistive loads. Now we move to an LED load, which is a highly sophisticated, smart energy saver that runs off an IC. Same thing, back in those days, we used to have stairs to go on a floor to floor. Now we have elevators and we have escalators. The manufacturing process has been significantly changed, adding robust robotic arms or pretty PLC machines, CNC machines, and everything, which are pretty fast and efficient. Even the power generation, conventional generation has been switched to from hydro to solar, and also to the wind and the renewable energy as well. So basically what we're doing here is, like even the computers, small computers to a high energy hoggers, such as the data centers. There is technically, what we are doing here is, we are switching away, we are actually moving away from traditional loads to the sophisticated electronics, right? So what happens on an engineering perspective? As I said, we're not living in the world of incandescent and bulb, space heater, induction motor anymore. We moved away from these linear loads into non-linear loads. The modern equipment is highly digital, programmable, and computerized. The loads are smart with ICs, switching devices, and many more. The loads are fast, efficient, and smart, as I said. What happens here is the loads are constantly changing their operating voltage in order to output what they're supposed to do. Like for example, they're going from AC to DC and then DC to DC, DC to AC, they're switching. And in order for them to switch, they are actually toggling at a 20 to 300 kilohertz switching frequency. By doing it so, these loads are accomplishing what they're supposed to do, and then now they're called SMPS. They're also called SMPS, switch mode power supplies. The ICs switch at specific frequency to achieve this designed DC output voltage. Okay, so the bottom line is now we are moving away from traditional loads to switch mode power supply modes. So what is the change that we switched from a traditional loads to the switching loads created? I would say this is just create electrical noise into the system. This is used to be the traditional sine wave for a traditional linear load. Now the non-linear load is adding all the hash, noise, transients, high frequency noise, and also harmonics on the sinusoidal wave, making disruptions in the voltage. Here it used to be a high third harmonic traditional induction motor loads. Now with the addition of nonlinear loads in the facility that are switching at a higher frequency, now you can see that the noise has been substantially increased on the higher frequency spectrum. Again, the perfect sinusoidal wave is no more sinusoidal, and then the frequency spectrum, the high third harmonic are no longer high third harmonic, but they are all over the spectrum. This is because of using the SMPS, switch mode power supplies, in a facility. The other thing we see in a facility are lightning strikes and the power grid failure, which is pretty common in Philippines market at this moment. Here's an interesting factor. Everybody thinks that the surges, the external noise, the transients always come from lightning strikes and the power grid failure. But in reality, they constitute about only 15% of the total surges. This is coming from a huge data they did in United States. 15% of the surge come from outside, whereas 85% of the surges and noise comes actually from within the building, which means basically from the nonlinear loads. These statistics are from United States. I do not have a lot of data from Philippines market, but this is on an average, a house, this is on an average, on a house will subject to about 200 surges, the damaging cost of about $8,000 for each surge event in the United States. I'm pretty sure the dollar value maybe is not significantly high for Philippines market, but I'm pretty sure the number of surges your facility is going through is substantially larger than these 200 surges. But again, you have to remember one thing. This is only 15% of these are coming in from outside. You might know how they're coming through. I'm not going to spend a lot of time in here. You have an electric pole. The surge actually enters through the ground into the system in external transient event. And internal transient event, here are all the nonlinear loads from washer, EV station now, TVs, computers, battery charging station, dish antenna, and everything. They have been generating tremendous amount of internally generated surges and transients within the system. So now what are the consequences of these electrical noise? There are many power quality issues that are caused by the surge and the noise. I would separate them into three categories. One is protection related issues, which can cause damage to the system by the surges, high voltage peaks and transients. And the second one is a performance related issues, which decrease the load's performance when they're hit by the electrical noise. Like for example, people call ghost in the system, right? Like, they just shut off the electrical conveyor belt because they don't know what's going on and they just have a sporadic issue. They have to reset the breaker, they have to reset the motor, they have to reset the whole system again. So it decreases the performance. So that is the second issue. And the third one is very obviously energy related. The electrical noise is an unwanted energy, is a wasted energy. It's going to cause a wasted energy. They will heat up the transformers, heat up the wires, heat up your electrical load by consuming more energy from the mains, which means that you eventually going to have your power bill is substantially larger every day by day as you're adding more nonlinear loads. So again, categorizing the consequences of the electrical noise in the system, I would say they damage your equipment so that they are burn your circuit boards and damage your equipment instantly and decrease the performance of the system. And the third one is they consume more energy and they decrease the efficiency of the system. Now, there is a serious I want to talk about there is a serious misconception on the efficiency and the performance of the electrical loads in the facility. They think that the only reason for the low production or efficiency or performance is the mechanical stuff. It's not true. I don't agree with that at all. It's that food that the machine is eating, which is electricity. If you have a poor power quality, if you have electrical noise on your system, it will impact the performance throughput of the system. We have many case studies that coming in from Japan, United States, China, and also even Philippines, which proves that by reducing the electrical noise from the system, you can improve the performance of the system and you can decrease the energy consumption of the particular load. Now, again, I just want to sum it up with one more by saying that ohmic losses is what we all learn from textbooks and everything. These are all the losses that you see with the noise in the system. So while we have seen the problems that are created by the electrical noise or the poor power quality in a facility, right? Now let's talk about the solutions. What we could provide, what we can bring into the table here today is we can offer protection to your facility from lightning strikes, from the surges, from all the electrical noise, all sorts of electrical noise in a facility, and we can prevent those unexpected repairs and maintenance costs caused by the electrical noise in a facility. And the third one, most important thing is we increase the efficiency of your system. We optimize your electrical system to perform at its peak efficiency with reduced energy bills. So these are really good things, what we call PPO. We protect the facility, we prevent the unexpected accidents in the facility, and we optimize the electrical distribution system by reducing the energy. Let's see how we're going to do it. Here is a high-level picture. Here is a EP solution for the higher order harmonics and also the transients. You see on the left-hand side, the electrical signal is pretty noisy with the transients and everything. So we will address the harmful electrical transients by using what we call component A, thermal metal oxide varistor, which is called a TMOV, that complies with the national and international standards like UL 1449. And we address all the hash that you see on the waveform, which is a nonlinear components electrical transient noise, by using electrical low-pass filters. So by applying EP filter, you will see a clear sine wave after adding EP filter. And traditional comparators only take care of the 20% of the noise, which is right here on the box, and they dump it to the ground. And they do not care about the transient noise or the electrical noise or what we also call the ringing noise in the system. EP takes care of both the high peak, high energy transients and also the high frequency noise in the system. So I know you're all engineers, you would understand this. I would like to take one step ahead and I want to explain this scenario here. This is a T-mount that actually connects on a phase to the neutral, which actually dumps back to the neutral. But what matters most here is that surge is not one single event. It is a ringing transient. It is a ringing decay function, like an exponential function, as we learned from the school. So that ringing noise is something that has been captured by the low-pass filter and also dump it back out of the tank circuit. So what essentially we do here is we divert the surge energy back into our tank circuit. We clean up the ringing noise by using a low-pass filter, and we use the tank circuit to safely dissipate all the massive amounts of energy, surge energy, electrical noise energy into our unit itself. So our unit is a metal case that actually adds an advantage for us because it actually really acts like a perfect heat sink. The next picture is a graphical representation. All the bad electrical signal, the poor power quality, or the non-sinusoidal waveform getting into EP. Now we are correcting the waveform. That is how we got this name as a waveform correction technology. As you can see here, after passing through the EP filter, it's beautiful. Now, what are the benefits we are actually adding by correcting the waveform, by removing the electrical noise in the system? It's obvious. We just talked about a few minutes back. We protect your facility from all the dangerous, harmful effects of the surges. So no more circuit blowouts, no more TV blowouts, no more VFD blowouts or anything. And we prevent those unexpected repairs and maintenance costs. So you will reduce the operating expense on these units, on your facility by properly utilizing EP filters in a facility. And we increase the efficiency of the system by reducing the heat in the system on the transformers, on the induction motors, on the wires, on the unit itself. Therefore, you consume less energy from the main. Basically, you just save money, capital investment, and also operating expenses in your facility by using EP filters. The most important thing is today the facility has been changing constantly, adding non-linear loads. Now it's a smart, like you clap and the lights turns on. That kind of a smart technology we're living in, right? But everything has to eat the same food, which is a 50 or 60 cycles, 220 volts coming in from the main. It is your primary responsibility to make sure that you update your technology, you update your electrical distribution system to meet with the high demand of the smart technology. EP is the one that bridges gap between your traditional distribution system and your smart loads. So we perfectly sits in between these two, making sure that all your sophisticated electrical loads will get the clean power supply for its operation. So here are some of the filters that we offer based on the application, different filters. One actually goes on a lighting panel. This goes on a DIN rail mount. This is ground filter. We have all these units available in our trade booth now. You can go and check them out. We have EP 2500. We have a 2800 that actually highly modular case that can be installed up to 4,000 amps, or actually we even install at a 5,000 amps applications. So in a nutshell, we have a solution all the way from 5,000 amps main electrical panel to 1 amp small tiny LED driver. We can address pretty much everything in the market, all voltage configurations, and everything has been tested and installed in Philippines. They are being certified by UL 1449 tradition and also EMI filter certifications. We also have application specific. This is something we take extreme pride in because we designed this product from the Philippines market, which really got a very good attention, which is a residential protection. And we have a high-end audiophile market as well for data centers and hospitals. We installed in many of Tokyo hospitals and also United States. And we have OEM applications. Let's say you have an existing LED drivers and everything that you want to use. Then in order for you to extend the longevity of your predictive lightings, we can use OEM lighting as well. Here is how the product looks like when you installed on a main panel. It's actually right snug into the electrical panel. We have many more pictures. Our team members can help you in showing how the unit looks like and how it looks like when installed on a panel. It's not complicated to install. Assuming you have a very good gear, assuming you are a certified electrician, you only take 20 minutes to install. Having a proper prep and everything, 20 minutes. There is nothing to prep. You just open the box and install directly on the main panel, trim the wires and install. So it's very simple. It's not assembling. It's not like an assembly of a furniture or anything. It's just ready to go, coming from the box from Salt Lake City. You just install main on panel under 20 minutes. They come with a huge warranty, 10-year warranty. We've been in the business for 25 years, so we rarely have any returns. We've been sold to 8 different countries and proudly made in USA. So here's the most important tagline. Who works 24/7, right? We work 24/7. Environmental potentials work 24/7, protecting your facility, helping you just sleep well, because now you don't need to wake up for the maintenance calls and everything now and often. Typical installations looks like this on the top of a cabinet and inside a cabinet. As you see here, right here, main switch gear and everything. So this is about EP filters that we sell to the United States market and also to the Philippines market, and which been successfully proven. One other thing that I want to talk about today that we do for the Philippines market is a power quality reporting. We have been getting a considerable attention on these reports. We have our own tools, what we call PowerSight 4500. They are manufactured in the United States. These power meters are pretty expensive, $10,000 pop. We actually have many of those units in our engineering hands in Philippines. They go there to the facility, like they were in Meralco in EDC a few days back, spending about weeks and weeks of data log and everything, just trying to understand what's going on in the facility. They help us to understand the load behavior, understand the transient, understand the voltage sags, pretty much everything that you can think of. Just we dig deep into the 5 eyes to do the problem solving and root cause analysis, and then we figure out types of issues the facility is going through. And then the most important is we do a recommendation. It does not need to be an EP filter recommendation, but it can be any generic information like upgrade the transformer, clean up the ground lugs, or just install a harmonic filter, install voltage stabilizers or AVRs and everything. So we actually do a complete assessment of the facility based on the standards and the compliances that the country accepts, and then we do a very good full comprehensive report. This is the best thing we could do in Philippines market. A lot of facilities like Enomoto Corporation and few other companies, they really got a huge benefit of it, because now you can, it's a preventive. So why do you go to doctor every year, even you don't have a problem, right? Just to kind of be ready for unexpected things. That's exactly what we do by PQ reporting. You don't know what's going on in a facility. We will be there to help you out to understand the health of your facility. Okay. So it's pretty much, we recommend a PQ solutions and custom design solutions. Let's say you come up with a like an extremely rare requirement, a custom requirement. We're happy to design a low pass filter. We have done that for a mining industry, oil and natural gas, and a lot of other fields before, and we do the PQ reporting. So here is some of our Philippine industry partners. It's a pretty big, and I'm happy to dig deep into any other testing if you want, but I don't think I have a lots of time here. But if you have any questions, I'm available here. This is one of our surge testing on AEP filters here in the United States, where we compete with the other two pretty famous competitors, Cytronics and Cutler Hammer. As you can see the green line here, we substantially decrease the value of the surge all the way to 70 amps, when there's a few hundreds, some thousands of amps of surge has been put on EP unit. See the yellow line and blue line, it's still left over with the residual surges, what we call lead through voltage. As you see here, this is what I was talking about, the ringing noise, the negative peak and the positive peak. This is the one that actually affects the capacitance of your system, substantially decreasing the value of capacitor in any electrical equipment, and then it affects the performance of the system. So it's like, think of this way, every one surge you hit, you get about 10 different small surges, just like an earthquake. You know, you have a one major earthquake, and then you have 10 or 15 other turbulences happen after the earthquake, right? Major, like aftershock. Same thing with a surge. That's a ringing transient. That ringing transient has to be taken care of. If you don't have our patented waveform correction technology, we would be releasing the ringing noise back onto the system, but we are not. Here, look at this green line. We don't have any negative swing and a positive swing left over after the unit is subjected to the transient. Similarly, we have, this is a high frequency noise test on a EP filter. You see all the black and green blue line, which is the voltage and the current high frequency noise before adding EP filter. They actually completely flat down to the ground after we add a EP filter. Similarly, we got surges coming in from Toyota, from Japan, from Taipei, from China, from US, from Canada, and a lot of different other labs across the world. We're happy to share all this information with you. This is one of my favorite. There is a communication channel issue going on with the VFD, where we increase the performance of the system by adding EP filters. As you can see here, look at this noise. The one I'm showing right now is the communication that lays over with the power line and that matches with the signal, whereas you can see a lot of noise across the spectrum before adding EP filter. So we cleaned up everything and making sure that the customer or the receiver has a proper communication signal. This is actually Alaska pipeline from ConocoPhillips. So we got healthcare industry as well. We got magnetic relays. So we got numerous number of case studies that we can share with you. If you have any questions, here is the email addresses that we have on that you can reach out to. My name is Naveen again. My email address is the second one, naveen@ep2000.com. We have more data and documents available on our website anytime you're interested to. With that said, I sincerely would like to extend my thank you to IIEE and also EP Solutions Philippines, and to the Department of Energy and Department of Philippines and Department of Commerce of United States, the Consular Services of United States, who really helped us to increase our presence and the business into the Philippines. And with that said, I'm going to take a break here, and thank you again, once again. And if you have any questions, please visit us on our website, ep2000.com, or call us or email us for anything that you may want. Thank you so much, and I'm open for questions.